Hello, everyone. Welcome to the SQL Server on Linux and Kubernetes from Zero to Hero session. My name is Tejas, and I'm Principal Program Manager with Azure Data Group. And I have Amit Khandelwal here with me in this session. Amit, why don't you introduce yourself?
Thank you, Tejas. Hi, everyone. Welcome to DPS Data Platform Summit 2022. Very excited to be here again this year. Last year was awesome. We had more than 3 sessions, and this year we are back here with new developments. Before we talk about SQL Server and Linux and Kubernetes, let me first introduce myself. My name is Amit Khandelwal. I'm a Senior Product Manager or Technical Program Manager with Microsoft working on SQL Server and Linux and containers. So, if you have any questions on containers and Kubernetes and SQL Server, then both of us are the folks that you should be reaching out to. Over to Tejas, let's see what we basically have in this session. So let's do this. Let's actually do an understanding of what agenda we have. The first thing I want to talk about is a season 1 recap, which is all the 3 sessions that we did last year, what we covered in those, because that will be our foundation for this year's session. Then we are going to go ahead and take a look that if you want to get started with SQL Server on Linux and Azure, how do you get started? What are some of those options that you have? So we are going to ask Tejas a lot of questions here. Then we are going to go ahead and talk about SQL Server containers and Kubernetes, personally something that I really am passionate about. So Tejas, you can ask me questions on those on that particular topic. Then we are going to look about, and this is one topic that I really want to stress and spend some time on, that if you are looking to deploy SQL Server containers or SQL Server and Linux in production environments, especially with Kubernetes in picture, what are some of the considerations that you should be looking at? How should you be deploying an OLTP environment with SQL Server containers? That is another topic that we are going to talk about. Of course, with SQL Server, how can we keep high availability out? That is going to be another agenda that we are going to talk about. And SQL Server 22 upcoming new release, red carpet all laid out, drums roll beating. We will talk about the SQL Server 22 as well, because that's something special, and especially we'll talk about some of these Linux specific improvements that we have. And then of course we'll give you the references using which you can go ahead and get started by yourself. So as you can see, we have quite a loaded session. And Tejas, do we have any demos here?
Yes, we do. We have quite a few demos on various different topics. Please stay tuned, and I'm sure you will enjoy the entire session.
Awesome. With that, I think it's time for us to quickly recap what we did in season 1. So the first things we looked at was the different, the basically the history of SQL Server containers itself, where we started and where we are today. We also looked at the different deployment options that you have with SQL Server containers, as well as SQL Server in Linux, where you could deploy it on premises, or you could deploy it on public cloud like Azure. In Azure, you could deploy it on managed Kubernetes clusters. You could deploy it on unmanaged Kubernetes clusters, on VMs, on Red Hat based OpenShift clusters, which are again opinionated clusters. You could go ahead and deploy it there. So we spoke about all those options. Then we also spoke about the benefits overall that you get with SQL Server on Linux as well as with containers. And then we spoke about some of the scenarios that we have seen our customers use. That could be in DevOps, that could be for test and functional testing, it could be for OLTP deployments that you have for production workloads. And then we also looked at one more important topic, which is how you can automate your deployments for SQL Server containers on Kubernetes platforms using Helm, which is mostly considered a package manager for Kubernetes. And then we also spoke about the support policies, that if you are creating your custom container images, which you can, what are some of the boundaries that you need to know about, because those are some of the guidances and recommendations that we have that needs to be followed to ensure that you build a supported SQL Server custom container images. And last but not least, what we also spoke about are the different monitoring options that you had with SQL Server containers and SQL Server on Linux, which you could deploy on a TIG stack, which is Telegraph, Influx, and Grafana stack. So all of that we covered in three different sessions. So now let's get started with what we are going to do in this session. So first, Tejas, question time. Can you tell me that if I'm someone new to Azure and SQL Server on Linux and I want to get started with SQL Server on Linux, how do I go about it?
Thank you, Amit. That's a great question. So, as you know, we support SQL Server on multiple distributions. We fully support SQL Server on Red Hat Enterprise Linux, SUSE Enterprise Linux, and Canonical's Ubuntu LTS flavor, as well as Ubuntu Pro flavor with additional features in Azure environment. So now, over a period of quite a few years, we have been working with several of our customers quite closely, and we have learned quite a bit about common deployment patterns. Based on our learnings of these common deployment patterns, we have pre-created certain images, like SQL Server 2019 with RHEL 8 HA built in. So you don't need to install the pacemaker components. Or SQL Server 2019 with SUSE Enterprise Linux with HA also built in. We also have some pre-created images for SQL Server on Ubuntu Pro. And this is a special image because this comes with full stack support from both Microsoft and Canonical team for Ubuntu OS components as well. So we have pre-created some of these images for you to deploy your any kind of combinations that you desire quite easily in Azure ecosystem.
Wonderful. So that means I don't have to then install SQL Server. I can just use this and I have SQL Server already pre-installed, pre-configured, and ready to go. That's fantastic. Now,
absolutely. Absolutely.
Now,
In fact, I have done some, I have created some test environments and I have been able to deploy a VM based on this kind of configuration in under 3 minutes. That includes OS configuration and SQL configuration fully done and ready for you to use.
Wonderful. This is fantastic. Now, there is one more question that I always have. What are some of the best practices that we should follow for SQL Server on Linux? Are they different from SQL Server on Windows? Is this something that we should be aware of? Can you talk a little bit more on that, Tejas?
And that's an excellent question as well. Here is the thing, SQL Server is SQL Server, whether you run it on Windows or Linux environment. Most of the practices are quite pretty much the same. Especially for example, let's say you are thinking about deploying your SQL Server VM in Azure environment. Then the very first thing you would do is choose the right VM. Based on the number of cores you require, based amount of memory you require. So that's where you start, and then you add the storage based on the IOPS requirement of your workload. Then you figure out how to attach the storage and maybe isolate the files to special to certain drives. Maybe even add a few drives in a striped environment for higher resiliency as well as better performance. You enable enable host caching in certain cases and disable host caching in other cases. And we have some optimized configuration with TuneD component, which is provided by the operating system. You can use TempDB for using ephemeral disk as well, which is basically similar to what you would do in case of SQL Server deployed on Windows in Azure as well. And you can use VMs with accelerated networking for better improvement. So the overall consideration for deploying SQL Server in Azure are very much the same as that you would have for SQL Server on Windows as well. It's just that some of the OS related details might be different. So for example, you may want to choose in a certain in case of Windows, you would use NTFS for storage. In case of Linux, you would probably want to use XFS for storage. So these are the minor details but overall consideration for deploying SQL Server in Azure they remain the same.
Awesome. That is good. Last question on this stage is when you say choose the right VM, there's so many options. You have E series, you have M series, you have D series. Which ones to go with, and how should we be making those choices? Can you speak about those as well here, please?
Absolutely. So here is the thing, different VM series were created with different kind of workload in mind. And depending upon your workload, you will probably want to consider how many cores you need, how much memory you need, and based on that, different series are more optimally tuned for for your SQL Server deployment. So, for example, if you have very high OLTP, highly high throughput OLTP environment, and you need some extremely high performance system, then you probably will want to go for E series VMs. And N series VMs are also very high performance VMs as well, but they are great for mission critical workloads. And then there are D series VMs, which are a good entry level VMs. They are meant for more dev test environment, or you could use it for production environment for smaller scale workloads where it's not exactly a mission critical workload, but it is important for your company. D series could offer you a good combination of price performance at that point.
Wonderful. So it's all about the core to memory ratio that you need to keep in mind when you're making those choices, and how and where do you want, what kind of IOPS you're looking for. And based on
Exactly.
that is where you make those choices. That is absolutely wonderful. So now going next, let me talk about something that I did, Tejas, in terms of a demo that I set up using one of the Ubuntu Pro images, because I want to go ahead and say, wanted to see how easy it is for our customers to go ahead and deploy. As you can see, the offer that I've chosen here on that first screen, you can see it's actually an Ubuntu Pro Azure Marketplace image, which I used. And I went with an E series database because I wanted to run a TPCH benchmarking on this machine. So I wanted a machine that had about 32 CPUs and about 256 GB of memory. So that's why I went ahead and made that choice. Then I remembered that you spoke about using the optimal number of data drives and disks for your data files, separating your data files, log files, and also ensuring that you enable host caching. And I remembered that you said never to enable read-write caching for data files. So that is why I went ahead and enabled read-only caches. And then for data drives and for log, no cache at all. So you can see two disks being added there without any caching. And then I used two for TempDB because I knew I'm not going to be using a lot of TempDB. So this is how I basically went ahead and used. And then what I also did was enable the accelerated networking to ensure that we don't see any packet drops or any latency in terms of network. So that is another thing that was enabled. And good part, it was enabled by default. I really didn't have to do anything here. Then another important aspect that I did was I went ahead and like you can see in the last command, by default, I saw that my MS SQL tuned profile that was active on the machines. That means my server was configured to run the database workloads more optimally than any other workload. So that's why you would see the tuned profile, which was set to MS SQL. And then one important aspect, file system. I ensured that I'm using the XFS file system because that I think is the recommended file system based on our information that we have. And then I also went ahead and ensured to set some attributes like, no logging of time in terms of what we are basically using, then ensuring the read write are available on these. So those are some of the attributes those that I also set up. So overall, with this kind of a system setup, I was able to get some good amount of performance from that particular machine. And I really want to talk about some of the numbers that I got from that machine.
So before we go there, what is FUA? I mean, I've heard this acronym, but can you maybe explain it to a layman?
Absolutely. And that's why I bought this slide so that I get a question on this. Now, FUA is basically an improvement that was driven by the SQL Server team, where we requested our partners, like RHEL, like Ubuntu team, to actually give us this facility where using the FUA bit, you can basically get an improvement in your read-write workloads, especially the write-intensive workloads by more than 50%. It basically is a capability to enhance your write performance for your databases. Now, one question that I get a lot many times, and by the way, Bob Dorr has written an amazing article on this, and I have a reference link added to it. But one question that I always get is, when should I use the FUA bit and when should I not use the FUA, and how should I change my SQL Server configurations with that? And to answer that question, here is the basic three things that you need to remember. If your Linux distribution is greater than 4.18 and it supports FUA capability, for example, Ubuntu Pro on XFS supports FUA capability, RHEL 8 on XFS as well supports FUA capability, and they have kernel versions running 4.18. Plus, your storage system has this FUA feature enabled by default. How can you check for that? You can just run a simple command as sg modes and then the name of your drive, and you should be able to see whether it's connected. By default, Azure VMs, you will see they are enabled. And if you're running SQL 2017 CU6 or the next versions of it, then you should go ahead and enable FUA using these set of trace flags. So you should enable the trace flag 3979, my mistake, and then you should enable control write through and disable the alternate write through parameters. If one of these conditions is not met, then for better performance, you need to ensure that you don't have 3979 enabled, you have 3982 enabled, and you should also ensure that both the parameters write through and alternate write through are enabled. So this is a basic setting which can give you a tremendous amount of improvement in your workloads. So Tejas, we spoke about how and why you should be enabling FUA. Like I said, I deployed that Ubuntu Pro SQL Server VM to actually run a TPCC and see the difference myself. And out of the box, without making any changes, I just deployed SQL Server, enabled FUA and disabled FUA, ran a simple test using HammerDB, and voila, I see there is almost 45% difference in the throughput between FUA enabled and disabled. The blue bar that you see here, the bigger the bar, the better the throughput. The blue bars are with the FUA enabled, and the red ones are, of course, with FUA disabled. And you can see the difference is quite clear. So that is the impact of FUA on OLTP workloads. Now, we've spoken about FUA, Tejas, and we've spoken about so many things. Can you help us go through this entire thing and summarize this for us, that when we are deploying SQL Server on Azure VM, what are some of the points that we need to consider?
Absolutely. So let's just go about it, one by one. First of all, obviously, even before you get over here, you have to choose the right VM, right configuration, right drives, and basically the necessary infrastructure to support your workload. Once you have chosen the right VM and the right images for you to deploy, then what you start with is essentially a tuned profile. Tuned is an application provided by the operating system, and it can help you configure quite a few of these parameters, which otherwise you might have to do manually. And then it will basically tune the server or configure the server to run in with optimal performance for database workload. After that, the next is choose the right storage layout. SQL Server supports both ext4 and XFS file system. At the same time, the general preference is to support XFS file system. If nothing else, for the simple reason, XFS file system supports FUA versus ext4 that does not support FUA. And then you configure the FUA properly on the storage, and there are additional configurations you can do, such as disable the last access date time on the file system, because it can help you improve the throughput. And there are many such such configurations, and there is a lot of such guidance. We have documented that in this particular page, the link that we have given, and it will basically guide you to configure your SQL Server VM in Azure to run with optimal performance.
Awesome. That is fantastic. I think it's time for us to now move to the next topic, which is SQL Server containers and Kubernetes. Now, I know you might have a lot of questions for me here.
Absolutely. First of all, I mean, let's just, can you introduce me to the Kubernetes and, why Kubernetes? What is that?
Yes. Now, before I do that, Tejas, we'll have to take one step back and first understand traditionally how the deployments have been. What are the different deployments that we've seen? At least I'm sure you must have seen in your career, and I've seen in my career as well. So, traditionally, when we used to go ahead with the deployments, the first type of deployment was more of about deploying it on physical servers where you basically had multiple applications. The problem there, though, was first you could not isolate in terms of you could not restrict an application to take only certain set of resources. So one application could actually turn out to be a runaway in terms of resources and cause a lot of starvation to the other applications. We were not able to use our resources in the best way possible, in the optimized way possible. Then we moved into another section of the layer, which was about virtualized deployment, where we had a hypervisor in between, which basically ensured that we could run multiple VMs in isolation, where each VM actually had its resources limited, and based on that we could define and optimize our resource usage on in terms of physical hardware. And then comes the next one, which is container based deployment, which is pretty much similar to what we have in the virtual deployment, but then we went one step ahead, and instead of having its own OS, we made it little lighter. What we did, we had the OS to be shared, and then we packed all the binaries, all the application requirements that are needed into a single package, and was made available, which meant now we are not doing installations, rather we are just doing deployments, which meant that you could do it what you do today on your laptop, you could pretty much do this on any other environment, because all your dependencies went with your container, and that's how containers were born. Now, with containers born, a lot of people started using it. And with containers being used more and more, think of a situation. Today, I have a container running. I have about 100 containers now running after about a month. And after about a year, I have 1,000 containers running. And all of a sudden, two containers go down. And now you need to manually go in, check which are those two containers which are broken, and then bring them up. Wouldn't it be easier if something else did this for you automatically? If there was something in the backend which could orchestrate, manage, and bring up a container if it goes down, or provide you the high availability, or provide you the required networking infrastructure to be able to talk to each other so these containers can talk to each other? That and more is what basically Kubernetes does. Kubernetes provides that environment for us. Now, for a lot of SQL DBAs, they just the best way I think to explain Kubernetes and its different components is when you do your first deployment. And I know setting up a Kubernetes cluster, it's in itself could be a big, a big task in itself. To make that easier, I would always suggest that if you are someone new to the Kubernetes environment, the best way to get started is use the managed Kubernetes clusters on public cloud, something like Azure Kubernetes Service, because it basically hides all the complexity of managing a Kubernetes and deploying one, because it makes deployment very easy. I will show in my next demo. I actually built a demo for this stages to go through each and every node, how you go about deploying SQL Server, what's a YAML file, how do you go about it. I discussed there about containers, pod, replica set, persistent volumes, worker nodes. Like in this example, you can see this is a 3 node, at least if you go with just the basic diagram, this is a 3 node or more cluster. with just one pod, which is running one SQL Server container instance, which means it's a SQL Server container instance using a persistent volume, which is outside the node. That means it's not a local storage, it's a outside remote storage that is being utilized. Why remote storage? Because if the pod goes down or node goes down, you still shouldn't lose the data that you have for your database. So that is where Kubernetes comes in, and how it makes easier for you to expose your containers to as a services to external world and to be able to connect. All of that is what I talk in the demo. So Tejas, let's do this for all our users. Let's go to our demo section now. Let's get started with this demo. In this demo, what I'm basically going to do is I'm going to talk about the basics of Kubernetes clusters. And in my case, the Kubernetes cluster that I'm going to use is the Azure Kubernetes cluster. Two reasons for that. First, it's on Azure, so I want to use it. And second, it's actually a managed Kubernetes cluster, which means a lot of things, a lot of complexity of handling and managing the Kubernetes cluster is done by the platform, in this case, the Azure. And thus it becomes easier for me, someone who's starting with a Kubernetes cluster, it becomes easier for me to get started with it. With that said, it's now time for us to go ahead and create the Kubernetes cluster. Now, before we create the Kubernetes cluster, one thing I want to quickly clarify is I'm actually using Visual Studio Code to actually show you all of this demo. Two reasons for it. One, I can go ahead and create notebooks, run commands, save the output, and share it with you. Makes life easier for all of us. And second, I basically have extensions that I can download, and using which I could actually show you and manage the Kubernetes clusters easily without actually needing the command line for every task that we do. So that's the reason why I'm just using the Visual Studio Code. With that said, the first command that you basically use is you log in into your Azure account and then set your subscription, where you're going to go ahead and create the Azure Kubernetes Service cluster. Now, creating Azure Kubernetes Service clusters is not very complicated. As you can see, it just involves two commands to get started with. The first command is to go ahead and create the resource group. So when you're creating the resource group, in this case, this is the name of my resource group. And this over here that you see is the location for my cluster that I'm actually going to go ahead and create. Now, once I create the resource group, I need to create the resource inside it, which in this case is the cluster. So I'm just going to say is AKS create the resource group name, the name of my cluster, how many worker nodes do I need in that particular cluster, what is the size of each of these worker nodes. So this size here, standard B4, basically has 4 CPUs and 16 gigs of memory, if my memory serves right. And basically, it's going to have 2-node Kubernetes cluster running once this command completes. As you can see, I'm not going to run this command now. I've already done this to save some time. And you can see here that the cluster is going ahead and created. Once this cluster is successfully created, what is the next step? Of course, the next step is to connect to that cluster. Now, to connect to a cluster and to manage a cluster, you normally would require a command line tool. For Kubernetes, we call that command line tool as the kubectl. So the kubectl is basically the command line tool using which you manage your Kubernetes clusters. And this is the same tool that we are going to install locally on my Windows client machine, the machine on which I'm running this demo right now. How do I do this? To install kubectl, you just need to go ahead and install this CLI, the AZAKS install CLI. Once you install this CLI, it brings the kubectl also with it. So this way you can start managing connecting to your cluster. Now, to connect to anything, you need credentials. Similarly, to connect to a Kubernetes cluster, the clusters that you see here, I'm able to see all of these clusters in my extension because I have configured my config file with the credentials for each of these clusters. And the arrow that you see here basically says this is the current context or the current cluster to which I'm connected. Now, how do I get the credentials and how do I download these credentials? You don't have to write a file for it. all you have to do is run this command, get credentials, give the resource group name and the name of the cluster. Once you run this command, it automatically goes ahead, and if you're running this on Windows client, it will go ahead and download the credentials to this config file, which is by default placed here. Can you change this? Of course. Then you need to add that into the path and ensure that you're able to connect to it. That's it. That is all you needed to do to get a Kubernetes cluster up and running and to connect to it. What is next? Next, what you've got to do is look at the different resources that you can create. Now, when I expand my cluster, you can see the different resources listed here. You have something called as namespaces. You have something called as nodes. As you might remember, we have two nodes because that's how we created our cluster. So we said, I just need the two nodes. So you can go ahead and look at these two nodes over here, that these are the two nodes that you have in your cluster. And these are some of the containers that are running by default without anything that you do. These are some of the default containers that are already running on each of these nodes. Now, you also have something called as workloads. Under workloads, you have different type of workloads that you can deploy. For example, you have deployment workloads. Now, deployment workloads are normally the workloads that you would deploy on Kubernetes clusters, which do not need persistent storage, or in other words, if the container gets deleted and recreated, you are okay with it because it's not working with something that requires persistent storage. What are stateful sets? Stateful sets deployments are those deployments which basically, even when you go ahead and delete and recreate these containers, they will maintain their definitions. They will probably be using mostly the persistent storage. Databases are one good examples which needs to be deployed as stateful sets. So when you are deploying SQL Server for production environments, stateful sets is what you should be looking at. So when you deploy this based on the number of replicas that you want to create, I will talk about what replicas are. You will see there is a specific order in which the containers get created, and you will also see there is a specific order in which the containers gets deleted when you delete these containers. Similarly, you have daemon sets, which are nothing but background containers that you basically want to run on every node as soon as the cluster starts up. That's what you could do. You could also create jobs and you could run, which basically, if you'd want to do, similarly cron jobs and more. So you could go ahead and deploy different workloads based on the application that you're running. Then you have network, wherein you basically talk about services. What are the different type of services? Now, what is a service? If you have containers running or pods running inside the Kubernetes cluster, you would want to be able to expose them externally outside so users can connect to it. For example, you might have a SQL Server container that's running inside a Kubernetes cluster. You would want some sort of a way in which you could expose this SQL Server to outside the cluster so that users can connect to it. The way you would do it is through services. Then there are multiple different services that you can actually, there are, I think, 4 types of different services that you can actually create: cluster IP, node port, load balancer. What each of these means is definitely written here, so you could go ahead and read about it. For SQL Server, if you are running on public cloud, you would end up normally creating a load balancer server with static IP, which means if the service is deleted and recreated, the IP address doesn't change, because that's how you would want your SQL Server to be, right? If you have your applications configured to a specific IP address, if the service gets deleted and recreated, you don't want to reconfigure your application connections if the IP address changes. So you could actually go ahead and have a static IP that you can assign to these load balancers. So similarly, you have other things. For example, you have storage. Now, I'm not going to go ahead and explain what different storages are, like what a storage class is, what a PVC is, what a volume are, persistent volumes are, because this in itself is a very complicated topic. But to just give you a brief idea, if you want to go ahead and claim or associate your SQL Server containers to have certain set of storage which is running inside a Kubernetes cluster, you need to do that through a PVC claim. So think of a claim, persistent volume claim. Think of a claim to be a request made by request for the storage made by a user through the container. So if a container needs storage, that's how it is going to be done. Similarly, what's persistent volume? It's nothing but a piece of storage that has been provisioned by the administrator. Now, if you are an administrator for the Kubernetes cluster, you will create multiple PVs depending on the different types. Some could be a fast storage, slow storage. Depending on that, you will create multiple PVs, and then you will ask your users to go ahead and claim for it. And based on the definitions provided inside the claim, Kubernetes goes ahead and sees which is the best PV to suit for it. If it doesn't find it, then dynamically also it can get created. Storage class makes life easier because you don't as an administrator, you don't have to create these many number of PVs ahead of time. Rather, based on the PVC claim that comes in, storage based on the storage class that has been defined, which basically defines different types of storages, dynamically a PV gets created for it. I know this could get a little confusing. So to make things easier, what I'm going to do is in the second demo or the next demo where we are going to talk about how you should be deploying a SQL Server container for production grade workload and how you should be deploying for test, I will be talking about each of these components. For now, just think of all of these resources under your cluster as different things where you could use. So the things that you need to keep in mind is namespaces, which basically is a way, if I have to give you an example, it's basically in Windows cluster, you had something called as application groups, right? Which went ahead and grouped few resources together. Similarly, namespaces provides you that isolation level where you can have multiple resources grouped together, and you cannot use the same name for the resource within the same namespace, but across the namespace you can definitely have resources which are named the same. Similarly, you have workloads, like I said, different type of workloads, the network dependency storage, configurations where you want to go ahead and create, let's say, an MSSQL config and make it available to your containers. You could do that. We are going to take a look at it. So we'll take a look at it, all of those in the next demo.
Excellent demo. Thank you, Amit, for introducing me to Kubernetes. But it still, leaves me a little confused about what do I do? What options should I select for a SQL Server in this environment? Because it's a little alien, and many people are just getting started with this, right? So, what would
Yes.
you recommend? How we get started on this?
Absolutely. So here are my recommendations. You should always use stateful set. You should use persistent storage. You should use QA setting. Oh, I said a lot many settings here, right? You know what, Tejas? To manage this and to talk about each of these options, what persistent storage is, what quality of service setting is, why should you even be setting resource limits for your SQL Server containers when running in Kubernetes? To talk all about this, I have another demo. So you will have to bear with me while I switch to the next demo, where I'm going to talk about the different options you need to look at when you're deploying SQL Server as a test or when you're deploying SQL Server for production workloads. So let's go there to my demo environment pack. Let's get started with this demo. This is going to be a little detailed demo, so please stay with me until the end. With that, let me first talk about, in this demo, what we're going to talk about is what are the various deployment options to consider when you're deploying SQL Server containers on Kubernetes cluster. Now, depending upon the usage that you have for the SQL Server container, you have various deployment options. For example, if you're deploying SQL Server container in a use case scenario where it's going to be used as test or a QA environment, or let's say a DevOps environment where you really don't bother whether the container gets deleted or whether the container stops after doing its processing and gets recreated because it doesn't matter to you, then in those cases, what are the deployment options you have? We'll talk about that. But if you need your SQL Server containers for production workload, where you're running OLTP applications and you need your database to give you all the output that you expect from an OLTP database, like a SQL Server running on Linux or on Windows machines, at that point of time, the deployment options are different. So now what we're going to look at in this demo are the deployment options for both these cases. With that said, let's start with the first case. case, which is when you're going ahead and using SQL Server Container for a test case or for DevOps, where you don't bother or where you're not really bothered about SQL Server getting restarted. High availability is not one of your key requirements. You're just looking to kind of run SQL Server Container based on based on DevOps and all of that. So with that, let's get started. Now, in this, what I'm also going to explain to you, or hopefully try and communicate to you, is what are the different objects that we are going to create during the deployment of SQL Server Container, because we need these objects before we can create the container. For example, the first thing that we need is, of course, the storage and how we can claim that storage through persistent volume claim that you see here. So as you can see, I am going ahead and defining a storage, and this is a YAML file using which you put all your definitions here, and then you apply this YAML file on kubectl through kubectl on Kubernetes cluster, which then goes ahead and creates each of these resources that you can see here. So you can see under the storage section, I am going ahead and initiating or creating storage class and then creating a persistent volume claim, after which I am going ahead and creating a workload. So here you can see the workload definition. As you can see, this is a deployment kind of a workload, which means the containers, when they drop and recreate, will lose whatever IP address information. The name of that container will be different, will have a different unique IDs. So it'll basically lose all of that information. So and one more important aspect, you can see this is highlighted in yellow. And if I just hover on top of it, it basically tells me that I have defined containers without any resource limit, which could starve other processes. So I am getting that information or warning that this container definition that I have does not have any limits defined, which means if this container starts hogging resources, it can take pretty much the entire resources from the worker node on which this container is running, thus causing starvation for the other containers that will be probably sharing the load on the same Kubernetes cluster. So let's talk about in detail. So what I'm doing first, I'm creating a storage class here. The name of my storage class is Azure Disk. Let me just zoom into it. Then I am going ahead and creating a storage class. The name of the storage class is this. And as you can see, this is provisioner. What does provisioner mean is how is Azure Disk made available to the Kubernetes cluster? This is basic. Think of this more like a storage driver, which makes the storage available to the Kubernetes. So I am going ahead and making the storage available to the Kubernetes, in this case, an Azure Disk storage, which is made from my Azure subscription. I'm making it available onto the Kubernetes cluster through this resource definition. And there are different variables to it. For example, what kind of storage is this? Is this managed, unmanaged? You could add to it. Now, whenever you see a provisioner to be something like Kubernetes.io, you can understand that this is an Kubernetes provided provisioner, which means this is not something that is external written. This is available through the Kubernetes. So this is provided by Kubernetes. The other way to do this is through the CSI based, which is the container storage interface, where you could write your own interface and bring your own storages to the Kubernetes cluster. Next, what I'm doing is I'm also going ahead and defining a persistent volume claim. So I am saying that my MS SQL data is the name of my persistent volume claim. I want this data, the size of this to be about 8 GB. So this is a disk that is going to get attached, or think of this as a storage that is going to get attached to my container. And I am the name of my claim is MS SQL data, and the storage that I am asking for this claim to be done is from the Azure disk, which I just created above. With that said, now it's time for us to take a look at the deployment that we are doing. So this is a deployment workload type. So definitely not suited for production workloads. This is more suited for dev test and when you want to get quickly started DevOps and kind of a workload. This is the name of my metadata. And this over here, you can see is the name of my instance, MS SQL instance. This is the group ID for MS SQL. You know that for SQL Server on Linux, MS SQL is the user and group that we use. Similarly, you will see various other things defined over here. You have the MS SQL, the image that I'm actually going ahead and using. These are the container definitions. As you can see, I am just going ahead and deploying only one container in this pod. So this deployment is just going to create one container, and that container definition is provided over here, which you see mentioned here. So this is the image that I'm going to go ahead and use, the 2019 latest. This is the container port that I'm opening up. So this is a port that I open inside the container. I've already created a secret. This is a way of managing passwords inside Kubernetes. You create a secret. So I've already created a secret. What I want to really show you is look at the second section of this, where I am defining what the mount path is. And this mount path will be supported by this PVC claim, which I created above. If you remember, this is the same claim that I created here, which is basically getting its storage from the Azure Disk Storage class that I created. So this is how I am uh, connecting a container. So I'm saying this is the mount path. So inside the container, this mount path will be supported basically by this persistent volume claim, which is basically supported by the storage class that we created. And of course, I need a way to have the service, the SQL Server container exposed. This is the definition of the service. So I am mapping the ports with the container port, and this is a service of type load balancer. So if I have to show all of this in action to deploy this kind of a SQL Server in my environment, all I've got to do is run this command, which is kubectl apply -f, and then this workload YAML file which I've created. This is the location I've created it. I just go ahead and deploy it. And once I deploy, you will see the container getting created. Let me just go ahead and run this to see if I can see the resources that have been created. Yes, so you can see a container creation is in process. An external IP address is already assigned. So if I go ahead and see the storage classes, you will see a new storage class getting created because I just deployed it, which is the Azure Disk. And you can see the provisioner here is the Kubernetes.io. And of course, if I go ahead and look at the persistent volumes to see if there are any persistent volumes available here, let me just go ahead and run this again. You can see a new persistent volume created, which is of size 8 gigs. And you can see the name of the volume over here. Similarly, PVC. Now, the important aspect. If I look at the pod, or if I look at the description of this pod, you will see that this pod is getting created at, and let me see if I can show you the size limit. Let me open it in the text editor. So when you go here, this is one place that I wanted to show you. If you want to deploy SQL Server for production grade workload, this needs to be guaranteed and not best effort, because here what you basically have done, you've not defined any limits, which means if SQL Server needs more resources, it can pretty much take all the resource that's available on the node, which means if there are multiple SQL Server containers running on that cluster, other SQL Server containers can be starved for resources. This is a similar situation that you would see on VMs when you're running multiple VMs on the same physical host. So basically, you need to define your limits, and that's what I'm going to show you in the next demo. So, but before I go there, let us go back to see if our container has been created. So let me go ahead and run the kubectl get all command just to show you that it will change from container creating to a running state. Let's just run one more time. There you go. So you can see I have the pod created. This is my pod, which is the MS SQL server. If I need to connect to this SQL server, I basically will use this external IP address with this port. Of course, I can change the port. I then need to also change the MS SQL config, and this is the deployment set ready. So if I go ahead and delete this pod, you will see and automatically the Kubernetes will create another pod for me so that I have at least one running instance of SQL Server available with me. So this is a deployment for SQL Server when it's running in the normal mode. Now let's go ahead and see when you want to deploy SQL Server for production workload, what kind of YAML file and what kind of deployment you should have. Now it's time for us to take a look at the deployment options that you have when you're deploying SQL Server for production grade workload. Now, before I start explaining this deployment YAML file, let me first go ahead and initiate the deletion of the other one, because remember, my Kubernetes cluster is very small and it cannot host so many containers at once. So let me go ahead and delete this deployment, which I did in the previous files. So I'm just going ahead and deleting those. All right, while the deletion happens, let's go ahead and talk about it. Did you see how easy it was for me to delete it using the extension? Otherwise, I had to run the kubectl commands, which is kubectl delete the deployment, then delete the services. So I could actually go ahead and do all this through the as simple as through this UI that's made available. Now, one more thing that I need to go ahead and do is I need to go ahead and delete the service that I have, the MS SQL deployment service that I have. So let me go ahead and delete this service as well. Yes, I want to delete this. All right, with that service deletion happening now, it's time for me to go back and talk about this. So again, in this YAML file, what we are doing, we are first creating the storage class like we did, and this is again based on Azure Disk. The other part that I want to show you is we are also creating a config map inside the Kubernetes cluster. What is a config map? It's basically a way of providing your configuration files inside the Kubernetes cluster, inside the container. So if you have, for example, in our case, I have this MS SQL config file, and I want to be able to mount it to my SQL Server containers. And this is probably a, you in your environment, based on your usage, you might have certain set of configuration parameters that you want to pass to all your SQL servers. So this is basically what I'm doing here. I'm basically going ahead and having certain values. So I could have agent enabled, always on availability group enabled, all of those parameters set here in the configuration file. So I pass this configuration file as an MS SQL config, and the name of my config map is MS SQL, and this is the config map that is getting created. And as you can also see, what I've done is I have changed the default path to user data for data directory, and for the log directory, I've changed it to user log, so that if I have multiple storage devices, I can then mount my data files, MDF, NDFs on a different location and log files on a different location. Similarly, if I have TempDB, I can mount it to a different storage. So that's basically the recommended way of deploying SQL Server databases, right? So that's what I'm doing. The next is the workload definition. As you can see, I am defining this as a stateful set deployment, which means there will be a certain order in which the pods will be created. There will be a certain orders in which they'll be deleted, as well as when the pods are created and deleted or recreated, at that point of time, it will maintain its persistence in terms of IP addresses and other things. So that is why we recommend that if you need for your OLTP requirements or for your database requirement, deploy it as a stateful set. Also, I am going to have two replicas, which means I am deploying two different pods, each pod running one SQL Server instance. In the last example, we just had one pod with one SQL Server instance. In this case, we have two pods with two SQL Server instances. Then what we have, we define metadata labels and all of that. We define this. The most important aspect that I want to cover here is to get the quality of service to guaranteed, which I showed in the last case was best effort. This is the most important part. I am defining my limits where I'm saying that this SQL Server container can only use two CPUs and only 6 gigs of memory. This defining this resource limit is necessary. Remember, just having resource request is not enough. You should have resource limits defined. And if your request and limits are the same, then you get a guaranteed quality of service, which means Kubernetes will ensure that you always get two CPUs and 6 GB of memory, whether you're using it or not. It will not be shared by other components. So you will get this amount of resources made available to you. That is one. Also, if you look, the way we define here is we create volume mounts. We basically create volume mounts. For example, this is one volume mount for my binaries. This is my user data volume mount. This is for log. This is for temp. And this is to mount my MS SQL config file. And based on the volume mounts that I've gone ahead and created, I also go ahead and create the volume claim templates. This is the persistent volume claim templates. So let me just scroll down and then zoom in again. So the number of volume mounts I have, that many number of volume claim templates I will also make. And each I have defined with specific requests. For example, the storage in this case is 8 GB, or you could change that based on the requirement that you have. One important aspect that I want to also share in terms of service, as you can see, I have specified a load balancer static IP address, which means if this service gets dropped and recreated, the IP address is not going to change because I have assigned a static IP to it. Now, from where did I get this IP address? On Kubernetes platform, on Azure Kubernetes, you can get this static IP using a simple command, which is mentioned over here. So using this command that you see, which is, let me just zoom out and now zoom in. Using this command, which is az network public IP create, this basically is going ahead and creating the static IP. And I take this output from here and then insert this output in my YAML file here so that I can basically go ahead and assign a static IP to it. So I am basically creating two services because I have two pods running one SQL Server instance on each of the pod. So these IP addresses are assigned to each of those SQL Server containers. With that said, all I've got to do now is to deploy this workload. All I have to do is apply this just to be sure that there are no other services. I can run kubectl get all to ensure that there are no other resources. Yes, there's nothing. So this should work for me. So here I go ahead and run my deployment. So you can see the YAML file is now running. You should see all the resources being created. So you can see the storage class was not changed because we didn't delete it. The config map file was already created, and it went ahead and created the stateful set deployments and the services that were needed. You can see the output over here. Now, if I just run the kubectl command again, you should see the containers being created, the MS SQL 0 services as well as the MS SQL 1 service getting created. Remember, I know the IP addresses that it's going to get assigned. The MS SQL 0 is going to be assigned this, and MS SQL 1 is going to be assigned this service as as I've defined in my YAML file. So if I go back here, or if I would want, I could actually go ahead and refresh this and quickly check the stateful set deployments. So I can just go ahead and expand stateful set. You can see a new stateful set created, and you should see two pods here. So I'm just expanding. Yes, you can see the two pods, and looks like they're all up and running. So if I just run this command again, kubectl get all, you should see them up and running. Let's just run it. Yeah, there you go. It's up and running, and these are the same IP addresses that I have defined over here, which is getting picked. So now if I have to connect to this SQL server, all I've got to do is I can just connect to this, and because 1433 is the default port, this should work without any problems. So I can go ahead and hit a connect. This is the host name. Database can be optional. I want SQL login, SA, and my password is star 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 star. And yes, I want to remember the password. Let's call this as MSSQL 0. There you go. So this is the thing created. I can connect to it. I have the kubectl get all running, and I can see my pods here. If I just run this kubectl describe pod and go to the text editor, in the last case, if you remember, the QoS, the quality of service that we saw was best effort. In this case, if you would see, you will see the QoS as guaranteed. This is what I'm talking. So this basically means Kubernetes is going to ensure that I have the set of resources available on this node for my SQL server to go ahead and run on this. So even if I'm not using all that memory, all that CPU, it will not be given to any other resource at that point of time. This is an important aspect. So with that, I think we are good, and we should now go back to the slides. Perfect. Now that we've seen how you can deploy and what are the different options when deploying SQL Server containers on Kubernetes, it's time for us to talk about the high availability aspect of it. So let's now talk about how you can go ahead and deploy high availability for SQL Server containers on Kubernetes using some of the technologies that you're already aware of. For example, always on availability groups. So if you want to deploy always on availability groups, today we have a third-party solution using DH2I that you can go ahead and use for Kubernetes services or for SQL Server containers deployed on Kubernetes or even on standalone hosts, where first thing you need to do is definitely have a Kubernetes cluster with you. The second thing that you got to do is you need to go ahead and create a custom container image, the Docker file for which is made available in our documentation that I'm going to give you as part of references, where you could go ahead and create a SQL server and a DH2I container. So the DH2I components are actually running in the same container where you have SQL server. You basically take this image, deploy it on the Kubernetes service, and then you configure the cluster, which is create the cluster. And then you, at the end, go ahead and create the always on availability group on top of this cluster. And optionally, if you like, you could go ahead and create the listener if that is something that you want to create with static IPs, of course, or you could also configure the read write routing URL where the connections can be automatically redirected to the primary. So that is
Amit,
something that you could go ahead and do. Yes, Tejas.
okay. So let me ask you a question over here. Why are we talking about partner clustering technologies instead of something that Azure SQL team provides?
Okay, that's a fantastic question, Tejas. Now, I'll have to take a step back and think about SQL Server on Windows. Now, when you are running SQL Server on Windows, when you want to go ahead and set up always on availability group, one technology that you depend on at that point of time to provide you the HA is actually Windows clustering, correct? Windows clustering, again, is a technology provided by the operating system or by the distribution itself, on top of which SQL Server uses that and then provides you the availability group or the high availability functionality. Similarly, for SQL Server on Linux as well, we have multiple partners. We have an ecosystem. And the good part about Linux ecosystem is a lot of players would be there in this system who contribute to the system. So it's run by the community. So you have a lot of technologies that provide us. In this case, for containers, we have DH2I. For SQL Server and Linux, we have Pacemaker, which is again a supported stack from both the Red Hat as well as from Canonical. Then you also have HPE Service Card, which is also a supported solution with SQL Server, which is also supported by the HPE team 24/7. So these are different technologies that we support because as SQL Server, we did not want to only be affiliated to only one specific technology. If the technology works the way we want it and if it's reliable, we support it as a partner, and then we go ahead and build on top of it. That is why you will see that we have multiple options with SQL Server and Linux. If you are someone who is more comfortable with UIs, you have options. If you're someone who's more comfortable with CLIs, you have options. And if you are someone who's more comfortable both, you also have options for those. So that is why we have so many options here. Hope that
Excellent.
answers your question.
Yes, thank you.
Awesome. With that, let's go ahead and now take a look at how you can go ahead and use high availability for SQL Server containers on Azure Kubernetes Service using the H2I. Welcome to this demo. In this demo, we are going to go ahead and deploy SQL Server always on availability groups for the containers, which are SQL Server containers deployed on Kubernetes. Now, again, in this case, what we are going to do is the Kubernetes cluster that I'm using is the Azure Kubernetes service. And as you can see, I go ahead and deploy the storage class. This is the storage class that I'm going ahead and deploying. Then I'm deploying SQL Server as stateful set deployments. Also, one important difference that you would notice is I'm actually using a custom SQL Server container image, which has been uploaded to my Azure Container Registry. As you can see here, this is a private repository that I'm using. And if you want to understand what specific or what customization have been done to this image, there is this Docker file, which is also available in our documentation that I'm going to share with you. And as you can see in the Docker file, I'm actually using the latest SQL Server 2019, installing .NET on top of it. And what I'm also doing at the same time is going ahead and deploying the DXE packages so that I have the software component of DX Enterprise as well as SQL Server running on the same container image. Post which, when I go ahead and deploy my SQL Server containers, again, the deployment is pretty straightforward. You will run kubectl apply the YAML script, and then when you list the resources, you will notice that we have now two SQL Server pods deployed, the price 0 and secondary 0. Now, please remember, in case of high availability that you seek with SQL Server availability groups, you need to ensure that you at least have 3 replicas. Because of resource constraints, I'm just deploying with 2. But if you need high availability or for production environment, then you will definitely need 3 replicas. But again, the third replica, the steps all is going to remain the same. It's just that you need to repeat the steps that you do for one replica. You need to repeat it for the second replica as well. And one more important difference that I want you to point out in the deployment YAML file is when you are creating the services, not only are we opening the SQL Server port, the 1433, we are also opening the 7979 port, which is by default the port used by the DX admin. Post which you now have your custom container image deployed, uploaded to the container registry. You also have gone ahead and used that in your deployment for SQL Server containers. All you've got to do now is set up your DXC software and DX Enterprise cluster, and then deploy SQL Server always on availability groups. And the steps that you need to do this is pretty straightforward. The first step is to activate your DX Enterprise licenses. As you can see here, now you can get the developer license for the DX Enterprise from this website over here. As you can see, here's the website using which you can access and get yourself the developer edition of SQL of your DX Enterprise. And then you have just 4 commands that you kind of need to run. Now, if you're someone who's very comfortable with UI, you could run this command using the DX admin, which I'll show you in a bit, or you could run it through CLI using these commands. The first step, activate the license. Second step, create the vhost. Third step, go ahead and save the password for the SQL Server user the DX Enterprise is going to use to connect to the SQL Server. The fourth step is basically to go ahead and add the availability groups. So instead of running tsql commands, you could basically run one single command from the DXCLI Enterprise, which basically is going to go ahead, create an availability group called as AGS1, where this is going to be the primary to start with. This is the name of my instance. This is the name of the user using which I'm connecting to into the SQL Server. This is the hashed value for the password for this user, which is the password that you saved in the previous step. And then this is the port number and the mode in which the replica is going to be added. And then you will see I'm also generating a one-time password because this is a password that will be used on the secondary to join to this cluster. With this, all you've got to do then is create the, go ahead and add the database. Test is the database name. And after which you can go ahead and start connecting to your availability group. Now on the secondary side, just three commands to run. The first one to activate the server, the second one to join the cluster, and the third one to join the availability group, which is similar to the command that you ran on the primary. The only difference is you will change the replica names to the secondary, and you're going to also have the same user one that can connect to the secondary with the hashed password and the port number and the mode in which you're going to connect. That's all. If you have one more replica, you just basically need to run these three set of commands on that replica as well. Once you do that, you are pretty much ready to go ahead and manage and use your DX admin to be able to do the failovers, to move around your availability group replica. You could pretty much, as you can see here, hopefully, that there is this availability group replica that has been created. Now, I ran all of these commands earlier to save some time, but it was as simple as you can see in the command shell that I just showed. It is as simple as to, to go ahead and run those set of commands. And if you want to go ahead and fail this over, all you've got to do is select the replica where you want and say start hosting on this member. It'll automatically become the primary and the other one will join as secondary. If your pod gets deleted, automatic failover will also happen, provided you have three replicas and not just two replicas, like in this case that I have. Also, you can use your availability group dashboards that you've been using for managing SQL Server. So you could pretty much use the same dashboard to view the state of your database, to view the state of your availability groups and all of that. So as you can see, I'm just opening up the dashboard now, and it's basically connecting to it. And you should see the availability group name, which I can click, and then I can get the rest of the details. So that's it. It is this easy to go ahead and set up availability groups for SQL Server containers using DX Enterprise clusters. And all of this is very well documented and made available in the references section. You can find more details on this. With this, let's go back to our slides. After the demo on the high availability for SQL Server containers, it's now time to talk about the new SQL Server coming to the block, which is SQL Server 22. And I am really excited about it. So Tejas, I'm going to introduce SQL Server 22 here to everybody. So with this, let me go ahead and introduce SQL Server 22. I am pretty sure that you all would be aware that the public preview is already out. And if you want to try this on Linux, of course, it's also available on Linux. You can go ahead and get started. There's a blog link that I've added here. You can go ahead and refer to it. You can see all the steps and you can start using some of these cool features right away. With this, let me first start about what do we have in SQL Server 22. Now, the first thing is this release is much more closer to Azure. You have features like where you can go ahead and set up a direct link to Synapse, wherein your OLTP data can be sent in real time to Synapse without any ADF pipelines that you kind of need to create. Direct link out of the box that you can set up to Synapse, and you can run your analytical workload right away, which is on real-time data movement that's happening. Or you can set up a DR using Azure SQL managed instance. You can right away set it up again, click, 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 and you're done without any ADF. And it's also very closely integrated with Azure Purview, which is a governing service based, which will help you classify your data, get the lineage for your data correct. All of that facilities are made available to you directly with the SQL Server 22. With that, we also have some fantastic query processing capabilities built in SQL Server 22. I am sure if you are a DBA, parameter sensitive issues that you must have seen with stored procedures, those must have been the nightmares. Good thing is you will not see any such issues anymore with SQL Server 22. And with that, we also have gone ahead and enabled by default, query store is now enabled for the databases. And we've got good amount of experience with query store because we have it enabled for Azure SQL DB by default. And with all that experience that we have by running a cloud DB, we now have put that experience into the SQL Server box that you see. With that, we also have some fantastic features around security, scalability, availability. One of my favorite is SQL Ledger, which basically brings in the blockchain technology right inside the SQL Server, centrally to the SQL Server at this point of time. And of course, in terms of scalability and availability, there have been tons of improvements in terms of always on availability groups, distributed availability groups, all of those you will see there's been amazing improvements there. And one of the most important improvement, which I think is something that Linux customers would love, and that is around data virtualization and ability to access object storage through S3 APIs. And that's something that most of us are going to love because using your T-SQL and SQL Server, you can not only query your internal SQL Server tables, but you can actually go ahead and query and backup restore your databases to an S3 compatible object storage as well. Some of the examples are Ceph storages that you have, MinIO storages that you have. You could actually go ahead and use those. With that, last but not the least, of course, T-SQL functionalities, JSON system function functionalities have been improved, where you have new system functions defined, which you could go ahead and use and start working with. So SQL 22 is loaded with capabilities. We have already released the release notes with the features, what will work, what will not work. So looking forward for you to go ahead and try those. All right, that was way too much. We kind of finished through in last 65 minutes. So with that, Tejas, do you want to talk about some of the references that folks can refer to so that they can get started?
Absolutely. So if you go to this next slide, this slide provides you links to many of the references, including the performance best practices, some reference architectures, including for VMs and the container scenarios. Then we have quite a few different feature or the functionality that you can test with SQL Server on Linux and containers, and we have all this functionality very well documented for you to use. And we have some additional documentation for enabling monitoring as well that you can using tick stack that Amit mentioned earlier. So we have got a lot of content for you to follow up upon. What you saw in last 1.5 hour was just the beginning of it, just the beginning of your journey. And we have a lot more content for you to go through to make you the next experts.
Absolutely. And if you have any questions around SQL Server and Linux and containers, please feel free to reach us. You could reach us on our email addresses that's available on the introduction slide, or you could go ahead and also reach us over social handles on LinkedIn or on Twitter. We'll be more than happy. And special thanks to all of the DPS team. Thank you so much. And thank you so much for attending our session. I hope this was helpful, and we are very excited for any questions that you might have. So let's go ahead and open up for questions. If you can't think of one now, and if you think of it later, just let us know over an email. We'll be more than happy to get back to you. Thank you all, and have a good learning ahead.